Light does not scatter through crystalline layer. Therefore, they are transparent. Okay, so this part is transparent. This is translucent. You can check even with these wax cloth or any sort of this polymeric something. Just if you see through light, you will see this. It's not always very clear. Like, but this clear sheet metal after this, those are very clear. So they have to come only with this demonstrated. Polythene can be synthesized so that a branch structure is obtained. Linear polythene molecules stack closely with each other and have more high density area. Such polythenes are named as high density polythene HDPE. When branched, the molecules do not pack that closely. Their density is low and have more amorphous regions. This type of polythene is referred to as low density polythene. Rubber and plastic. Rubber is considered as the polymeric material which possesses very high elastic properties. Reversible. The elastic properties of rubber can be controlled. Starting from monomers, the polymer for rubber can be synthesized. Those are known as artificial rubber. Example, nitrile rubber. Highly elastic polymer can be obtained from the latex of the rubber tree too. These are known as natural rubber. See, in the natural rubber, you can define this one. But in natural rubber, the process is not like inside the tree. Process is not like that. We have this normal it's very complicated, different process. So whenever you are making this rubber, it's become artificial rubber. It's not the natural rubber. Nature properties all are different. Polymers with limited elastic properties can be considered as plastic. For example, polymeric substances such as PVC, PET, PP, and PE are considered as plastic. When stretched beyond the elastic limit, its shape changes irreversibly. Plastic can be classified further: thermoset and thermoplastic. Thermoset are composed of linear polymer molecules or branch polymer molecules. Thermoset polymers have the molecular structure arranged as network. Thermoplastic, which came through linear and branch polymers, thermoset can be softened by heating. Therefore, they can easily be molded to the required shape by heating. The shape can be made permanently by cooling. PVC, PE, PS, polystyrene, are examples for this. But the thermoset, which have this network structure, thermoset polymers cannot be softened like that. Phenol formaldehyde or bakelite is an example for that. Natural rubber. Is the substance with high elastic properties obtained by circulating latex of the rubber tree. Hevia brasiliensis. Hevia brasiliensis. Rubber latex is collected by the systematic removal of the bark of the rubber tree. In rubber area, we have this rubber estate. Rubber latex contains 60 to 65% water and 30 to 35% rubber. In rubber latex, rubber occurs as a colloidal solution in which very small rubber particles are dispersed. Simple sugar and salts are also dissolved in this colloidal solution. In the middle, you have a rubber. And around that you have this protein and lipid layer. There is this lipid and protein layer around the rubber particle. Inner to it lie rubber molecule. Since COO groups associate the outer layers of the rubber particle, its outer surface is negatively charged like this. And as electrostatic repulsion forces, negative repulsion, operate among these negatively charged particles, they are spread through the solution like a colloidal suspension, no coagulation or no heating comes to these negative charges. And what happens when we have an acid or bacteria? It seems like this. Because of the repulsive forces among the negatively charged surfaces, the particles do not combine together. In addition of acids, H plus ions neutralizes the COO minus groups, and the surface of the particles become electrically neutral. Then the particles combine together and settle down as a mass. That is called the coagulation of latex. It's a good thing. We need to coagulate to make this the product. This coagulated rubber is called the coagulant. Such the rubber latex contains salt, sugar, amino acids, etc. It is a suitable medium for microbial action. That is the disadvantage. Because of the acid released by the action of microorganisms, latex coagulates. Therefore, after the collection of rubber latex, before it is moving into these factories, if they accept that is disadvantage, we need to set it according to our requirements, whatever the final product we can do. But we do not let this bacteria to set this rubber latex. Therefore, after the collection of rubber latex, its coagulation can be prevented by stopping the microbial activity till it is subjected to the production process. The coagulation can be prevented by basifying the latex by addition of ammonia solution. Ammonia prevents the medium, becomes acidic, and stabilizes the negative charges around the rubber particles. Under these basic conditions, the microbial action is suppressed. Let's say that it depends on the product that we are making. Rubber tree, rubber latex. If you are using like deep product, typically we have these molds of rubber gloves, hand shape, see my hand. So we can just dip it on this rubber latex. So ready to dry to make this glove. If you are going through that, you are not going through this coagulation process. But otherwise, we need to coagulate to make the rubber sheets, then various types of rubbers in solid state. Let's say smoke rubber sheets, they have these factories. Smoke area is there, so we are just hanging these rubber sheets and let this smoke pass to give this smoke rubber. මට ඕනේ අර chicken එකයි chickpea එකයි ඒ ටික උඩ සුජි chicken එකයි chickpea එකයි ඒ ටික උඩ fridge එකේ. Okay, various types of rubber at solid state. Product based on solid rubber, tires, slippers, rubber covers, different. In the natural rubber molecule, there are two natural rubber molecules. Okay, this is the natural rubber. These 2 points are these joining points of the next molecule. See, from here and from here. So what's supposed to be here before this? So this CH3 is just existing. C1 sigma is there, C and C. Then there's supposed to be this double bond and another double bond here and CH2, CH2. This is the monomer, understood? See, this is the monomer of this, but we are not making using this monomer. All right. In the natural rubber molecule, there are two CH2 groups and one CH3 group joined to the double bonded, see spelling errors are there, carbon atoms in a repeating unit. It is named as the two CH2 groups in one side. So we call it cis-1,4 polyisoprene. If these two CH2 groups are in opposite direction, that is what we're going here, that is called Mathotaarachchi. Mathotaarachchi has a trans structure. This natural rubber is known as this natural polymer is known as trans-1,4 polyisoprene. That's again natural, but it has trans-1,4 polyisoprene. It does not show elastic property. Mathotaarachchi does not show elastic properties. Elastic properties coming only with this cis-1. There is a maximum distance between the adjacent two CH3 groups in the trans structure. Polyisoprene can be made synthetically by polymerizing the monomer isoprene. It belongs to the category of synthetic rubber. They are termed isoprene rubber. In synthetic rubber, the monomer is isoprene, but we can say that it is the monomer of natural rubber. In the rubber tree, rubber molecules are produced by very complex biochemical reaction. Okay, so now we know that the rubber has the uncontrollable elasticity, which is disadvantageous to some. So we need to control this elasticity. To control this elasticity, we are adding sulfur. That is called vulcanization. Vulcanization of material. Existence of cis polyisoprene chains is the reason for the elasticity of natural rubber. But to change the elastic property of rubber as required industrially and strengthen it, it is heated with 1 to 3% sulfur. This is called vulcanization of rubber. During vulcanization, cross-links are formed among the polyisoprene chains by sulfur atoms, which decrease its elastic property by increase the resilience or the ability to regain its original dimension. Ebonite. Ebonite usually be at 1 to 3%. But ebonite percentage is very high, 25 to 35%. Ebonite is obtained when rubber is heated with 25 to 35 sulfur by weight. Ebonite does show elastic property. This is due to the fact that activity associated with the double bonds in rubber molecules form large number of cross-links with sulfur atoms. Rubber vulcanized with an optimal amount of sulfur is not sticky and processed and optimal elastic and higher mechanical qualities. These are the properties they gain by the vulcanization. They are not sticky and optimum elasticity is there and mechanical qualities are also improved. See? We can just show like this, these are the common features. And some of these linkages are thinking like this. This blue parts are sulfur cross linking. So when we are making this cross linking, this double bond breaks. If this double bond is not there when there is cross linking. See, these are the cross linkages. Alright, I'm going to cover additives used for polymer-related products. The substances used to improve the quality of the end product and reduce its production costs. In the production of polymers are referred to as additives. They are very good quality and also decrease this cost or whatever. Especially by using fillers, the volume required for the end product is obtained. Even the quality with polymer adding fillers to make it bigger or larger in good shape. In the production of tire, that we know using carbon black in production of tire, carbon black is used as a filler. Carbon black, this word is black, okay? Carbon black improves its physical and mechanical qualities. For example, it reduces the wear and increases the strength. But release of these carbon black particles to the environment cause environmental problems. My normal house is sort of all right. If you are not even wearing slippers, down of the feet not getting dark while you run the full house, we are using really low windows because it's in the center of this city center. So balconies are like each day they might be have to clean it. So dark. Inside is really alright because we are sealed. The full house is sealed. But release of the carbon black, okay. To make vulcanization efficient, various organic catalysts and catalytic promoters such as zinc oxide are used. Most of these organic catalysts are toxic. Various fillers are used to plastics as well. Calcium carbonate is one of them. In the production of plastics, compounds called plasticizers are added to increase their flexibility. For example, PVC pipes used to supply water are hard and rigid, but outer cover of the domestic electric cables made of same material is flexible. This is because PVC of the latter is mixed with plasticizer. Therefore, it gets flexibility. With plasticizer, we are getting flexibility. In addition of these, additives are added to reduce inflammability, not catching fire, and prevent the damage caused by UV or ultraviolet rays. Additives are added in small amounts. Most of additives added to plastics are phthalates, but phthalates are really poisonous. That's why you cannot use plastic. Best plastic I'm using for these microwaves are ice cream containers because they get used to go with these temperatures. I don't know, not exactly. Other than Pyrex glass containers, I don't use any other plastics because even if I bought with very expensive these plastic stuff, if you're subject to high temperature, they are bleeding. So I don't use them in plastics on my frame. It has been discovered that many additives disrupt the action of the endocrine system, see our hormone system. Hence, much attention should be paid when plastics are used as packaging materials in food storage. Production of plastic goods using PVC is a process where additives are simply used. The reason for this is that in PVC, chlorine atoms are bonded to secondary carbon atoms. Vinyl chlorine is unstable. Various additives are used to prevent the breaking of the CCl bonds because this is vinyl that we did for organic chemistry, if you remember. So that's really unstable. Because of the temperature used in the production process, or when those goods are exposed to ultraviolet rays, hydrochloric gets removed from PVC molecules. All right, we done up to page 47. Chemical products related to plant sources, vinegar, ethanol, those, let's do next day. Are you guys coming tomorrow to the class? I'm gonna ask this Nettie to bring because I gave her this that inorganic tutorial. You guys have this first from activity question. It's really now. She would come. She was like her mom and sister of PG in Australia, so that's why she didn't come last week. Anyway, okay, let's start the class there. Now take care of you before I'm saying the salary. Unit 14 is a must because now they are asking preliminary expectations. You both are really, really brave. I want to bring you to until mass so that I want you to do 14, just read. And I'm expecting it just you do not remember starting enough. Just read, that's enough for industrial and okay, 5 6.